Hello everyone, welcome to another episode of Cuda Education. Today we are going to talk about validation layers. So the purpose of validation layers basically is to assist developers in uh, creating code, source code, software, what have you, that is consistent with the spec, that is whole, that is robust, all of that good stuff. That's the general purpose of validation layers. Now, we kind of have to go through a little history. Um, Generally speaking, before Vulkan API, and especially when you're talking about OpenGL, computer graphics software, computer graphics development was a mess. Um, the foundation of computer graphics, which is in a lot of ways OpenGL, sort of had to, it started at one place and it had to evolve over time to keep up with changes in hardware, changes in times, changes in everything. And as a result of that, you found that it became increasingly harder and harder to ensure consistency in your in the interpretation of your source code, or in the implementation of your source code on various pieces of hardware. So whether you're talking about, an Intel, graphics hardware, NVIDIA hardware, AMD hardware, ATI, or whichever other vendor had a GPU out there, it was increasingly more difficult, because what would happen is that drivers and different hardwares would interpret the code differently. So basically, it was a mess. So a vendor, a video game developer, a software developer would ship a product on a CD-ROM or something, and it wouldn't necessarily work on the consumer's hardware because of some idiosyncratic reason, or however the software was interpreted, or things were done. So validation layers, in a nutshell, it's mainly a means of helping software developers to create code that is more consistent, more cross-platform, more robust. That can sort of stand the test of time and stand the test of various platforms and hardware situations. So the first thing that you have to note about validation layers is that validation and driver are separate and apart. So going along with my same story, in previous computer graphics frameworks, the driver and the validation were sort of one and the same. And of course, the driver was hardware specific, or vendor specific. So this is Vulkan's attempt to sort of clean up the situation, separate the two, so that you could do validation separate and apart from whatever driver is the hardware vendor is pushing out, or whatever the situation is. So validation allows you to keep track of stuff. It helps you in development, so that you know how fast things are going, what are the values of variables, etc., etc. And you can the second thing I want to say is that you could turn on validation during application development and turn off when shipping product. Okay, so when you're developing the code, and when you're trying to make your game engine or your application fast, and making sure that everything is correct and all the variables have the right values and all that stuff, you turn on validation. And of course, when you're doing that, the application would run a little slower because it has to do extra processing to make sure it can keep track of the variables and all the things that's happening in the application. But when you go to ship it, you turn off the validation layer. So that's sort of another clean attempt and a clean way that Vulkan is using to sort of sort out the mess of making code that is easy to debug, that's easy to validate, to verify, all that good stuff. And as I said previously, easier to develop, more consistency across hardware platforms. So again, this just means regardless of whether you have an AMD graphics card, an NVIDIA graphics card, some other type of Intel graphics card, something from Apple, what have you, you're supposed to get a little bit more consistency because the validation is separate from the driver, right? And Vulkan is platform agnostic, so it should be able to run on various situations. But again, this is just a direct attempt to sort out, debugging and verification and validation and all that stuff. Another thing that you want to keep in mind is that activating validation layers. Okay, so there are two ways to activate validation layers. You could do environment variables. Now I'm talking from a Windows environment because that's what my tutorials are based off of. You could do it from environment variables, and you could do it from inside the application. Okay? So basically, you could set a variable inside your application and then do an if statement. And if the if statement is true, validation is on. If the if statement is off, validation is off. And what happens usually with validation, when you have validation on, is that you get a lot of output in the command prompt about the state of various things. So normally when validation is off, you don't really get much output. The application just runs, you see your triangle, and that's that. But when validation is on, you get a lot of output about the status of variables, the status of various things, what's going on, all of that stuff. There is also a way to kind of manage activating validation layers, and that's through the Vulkan configurator. And that's part of the LunarG installation process, where it's sort of like an external thing where you could manage different layers and different things that you want to test and what have you. But it's sort of an external thing. I mean, obviously, when you're developing, or you're dealing with the code itself or the program itself, you'd want to either do it by environment variables or inside the application. The configurator, the Vulkan configurator, is something kind of separate with the LunarG, things like that. Another thing that I guess I should have discussed earlier is that with Vulkan, when it says the word layers, it's talking about different, I'm not going to get into it, but there are different things that you could ask for validation for. So it's not just, it's on and off and it's just a one switch. There are different layers of validation that you could ask for, and it gives you a little bit more granularity on just trying to validate the things that you care about, or the things that you're trying to develop, or the things that you're trying to debug, or what have you. So there are different layers of validation, and that is a powerful thing, because again, it allows you to hone in, to zoom in, to focus on specific things that you want to do, and yet not bog down yourself with feedback from things that you're not actively developing or care about. So you're able to focus on only what you want to validate. Your application can run a little faster because you're not just validating the whole application and getting all kinds of output. You're only getting specific, layers of your application of what you want to validate. So that's that's something that maybe should have been number one. Validate specific layers / activities in your application. This one is a very important one. It gives you a little bit more granularity and all that stuff. And then the last thing that I guess I want to talk about is the what they call debug callback. So in previous tutorials, when you go through my tutorials and what have you, everyone knows that Vulkan is run basically by instances. So you could manage events within an instance, and number two, you could manage events while an instance is being created. So basically, within the Vulkan framework, you could have many different instances, which are basically many different applications that do completely separate things, completely separate computer graphics applications. So you could manage events within an instance, and you could manage events while an instance is being created. Now, obviously, you might think that not only do you want to manage stuff while your application is running within an instance, but you also want to manage the actual creation of the instance itself, which is the manage events while an instance is being created. So that's also a very important thing, as you can imagine. The creation of a new application, the creation of sectioning off resources and configuring things and getting your application to start running and stuff. So this is just my basic nutshell on how validation layers work in Vulkan. Now, if you look at the description below, I will have a link to the tutorial. So I will have a tutorial that goes through the validation layers. We will go through setting up a validation layer, running validation layers. Remember, all of our tutorials have running code, and we dissect the running code on your machine, on a Windows-based machine. So we have running code on a Windows-based machine, and then we dissect the code, or we configure the code, we set it up, and we have it running so that you can play around with it yourself and develop your understanding and skills and learn how these validation layers work and what you can do with them and all of that good stuff. So This is just my quick overview of validation layers as far as I see it. Definitely check out the tutorial with the link below that goes through, how setting up validation layers and actually seeing it run, seeing it turned on, seeing it turned off. I think we do, yeah, we do inside the application. I don't think I do the environment variables. I do inside the application and I do the Vulkan configurator. So you'll be able to see that. But validation layers is another, what you would say, another great evolution of computer graphics software. And it's definitely an improvement over OpenGL because it's more straightforward, more consistent, easier to work with, and you could really get down into the you could get really granular about what it is you're trying to validate and verify and all that stuff. Now, I will also say that there is NVIDIA has come out with a tool called Insight Graphics, and Insight Graphics is basically a tool that you could run your Vulkan code inside of it. Of course, you have to have an NVIDIA GPU. So first of all, Insight Graphics, you have to have an NVIDIA GPU. But basically, you could take your Vulkan code, you could run it inside of Insight Graphics and get even more information. You could even get like GPU trace and more granular information about how the what's actually going on in your application, and you'll get like beautiful graphs and variable states and all that stuff. I actually do have a tutorial on Insight Graphics on Cuda Education too, so I will probably include a link to that in the description below. But again, Insight Graphics, you could only do that with NVIDIA GPU. So it's only available for NVIDIA GPUs, but I know they're actively developing it. Vulkan is fairly new and they're probably still trying to tinker with stuff, but that's also an area where you could use to get more information out of your computer graphics application. But again, let's just go back to validation layers. So yeah, validation layers is a very important tool in your arsenal of developing computer graphics applications. Thank you guys for watching. Definitely visit CudaEducation.com. Check out the store on Amazon. Get started with learning computer graphics. It's the future. It's everything is going digital now. Vulkan is platform agnostic, so it should be able to run on all platforms, and it should be able to run on all major hardware, GPU hardware manufacturers, right? So this is sort of the future, and it's well worth your time and energy to get on top of this stuff. So when it becomes the de facto means of generating graphics on computers, whether you're talking about Android, Linux, Windows, Mac, whatever, Qualcomm, whatever kind of Raspberry Pi, whatever kind of hardware becomes the new thing, you will be able to put a pixel on the screen. Anyway, guys, thank you for watching. Have a great day.